Welcome back. This is Mr. Hassan's Maths channel, and I'm answering question number 6 from November 2022 International A-Level Cambridge, paper 1, variant 3, pure mathematics paper from the 9709 syllabus from Cambridge. So it is given that alpha equals the inverse cosine. Find without the trig functions on your calculator the exact value of 1 over sine alpha. So here we cannot use our calculations, or at least the trig functions on our calculators, to solve this problem. So this is one of those problems which can be solved using trig identities, or can be solved using drawing a right angle triangle. So I'm going to, first of all, I'm going to show you both methods. I'm going to start off with the right angle triangle method. Okay, so a lot of students, they don't really like this topic. They say, oh, why can't we just... They told us not to use the calculator. They want to see the steps, okay, that are taken. Otherwise, it's just a bit of number crunching in your calculator. So the cosine of an angle is going to be basically 8 over 17. That's what it's told us. Okay, so if you know that alpha equals inverse cosine, that means the cosine of alpha is equal to 8 over 17. So let's say we call this, okay, this is a right angle. The cosine of the alpha is adjacent to 8 over 17. And therefore we can find this side over here, which is going to be the square root of 17 squared minus 8 squared. Now, if you find the square root of 17 squared minus 8 squared, give you square root of 17 squared minus 8 squared gives you 15. Wow, okay. So that's another Pythagorean triple, 5, 8, 17. 8, 15, and 17. 8, 15, and 17. So when you square 8 and 15, add them together, you get 17 squared. I knew this, 3, 4, 5, 5, 12, 13, 7, 24, 25. Here's another one, 8, 15, 17. Okay. So now, once we know that, we can work out the value of sine alpha, because we this is the hypotenuse, that's going to be 15 over 17. I can also work out the value of tan alpha. Alpha will be opposite of adjacent, which is 15 over 8. So now we have what we need to answer the question. It says the exact value of 1 over sine alpha. Now, if sine alpha is 15 over 17, 1 over sine alpha is going to be 17 over 15. And 1 over tan alpha is going to be 15 over 8. It's going to be 8 over 15. So we can say that 1 over sine alpha, 1 over tan alpha is equal to 17 over 15 plus 8 over 15, which is 25 over 15, which is a nice, easy number. 5 goes into both of those. That's 5 over 3. So therefore, 5 over 3. And that's a nice, simple using a right angle triangle. Okay, we could also use identities. Sine of alpha, as we discussed, is 8 over 17. Okay, so I know that there's a identity which links sine and cosine together, which is sine alpha plus cosine squared alpha equals 1. Okay, this identity links sine squared together. So I can get the cosine 17. Now remember, this has to be squared. It can't be sine alpha plus cosine alpha equals 1. No, it's sine squared alpha plus cosine squared alpha equals 1. And remember, cosine squared alpha is just the same as cosine alpha all squared. So this is going to be sine squared alpha plus, instead of 8 over 17, will be 8 over 17. That means the sine squared of alpha is 1 minus 64 over 17 squared. So we can say that the sine squared of alpha is equal to 1 minus 64 over 289. So you're going to have 1 minus 69, which gives you 225 over 289. 225 over 2. What we can say is that means that sine of alpha, therefore, is going to be the square root of this, which is 15 over 17. Okay, 15 over 17, that's the square root of sine of that. So that we get the same value for sine of alpha. And we have another identity that we know. Alpha is equal to the sine of alpha divided by the cosine of alpha. So the tan of alpha, therefore, is going to be the sine of alpha, which is 15 over 17, divided by the cosine of alpha, which we know is 8 over 17, which is 15 over times 17 over, 17 over 8. Good. These cancel out, so you're left with 15 over 8. That's the tan of alpha. Alpha over 8 is the tan of alpha, as we found before, and the rest is the same. You have 17 over 15, the reciprocal, plus 8 over 15 over 15. Remember, you add the numerators. The denominators 5 over 3. Okay, so that's two ways of doing it. One is using identities, and one is using triangles. This way is using, okay, trig identities, and that's using a right angle triangle. Both ways are perfectly fine, and we'll get you the full marks. Okay, so that question you have to remember. A lot of students say, "Oh, sir, why can't we use our calculator? Put 1 over sine of inverse cosine of 8 over 17 plus 1 over tan of inverse cosine of..." If you did that, you won't get any marks because you haven't showed any method, and they want you to do it without later in the trig functions in your calculator. You can do it for square roots and stuff like that, no problem. But for actually, using the trig ratios, you have to show these steps. Either you can show this diagram and what you did, or you can show using these two identities. That concludes this question, which is, I think, the only part of question 6. So question 6 is done from this paper. Other questions from this paper can be found in the playlist that will appear in this region over here at the end of the video. And over here, you'll have questions from my P1 collection of Cambridge to do with trigonometry, trig identities. Playlist over here. You can also find a playlist over here, which is dealing with trig identities and trigonometry of 2 of Excel. You can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.